This, I think, is the hardest question in the paper. It's a simultaneous equations question. So each week, Dan drives two routes, route X and route Y. I'm going to say on route X, he travels a distance of little x, and route Y, a distance of little y, because that's going to come into the next bit. 1 week, he drives route X 3 times. So that's going to be 3 lots of X, and route Y twice. So that's going to be 2y. He drives a total, that means I need to add them, of 134 miles. So I can create an equation from this information. And I think algebra is the way to go. I could try and represent this without algebra, but I think it's important to practice. If you practice this topic with algebra. We're then told another week he drives route X twice and route Y 5 times. So the total is then 203. Now, I'm going to talk to you a little bit about a different kind of simultaneous equation. So x plus 2y is equal to 5, and x plus y is equal um, to 3. Now, I can represent this as two sets of scales. I've got x and I've got 2 lots of y here, and that is balanced with 5. They weigh the same, so they're balanced on this set of scales. And then I've got another set of scales, x and y, and then 3. And what I can do here is I can basically, because this weighs the same as this, I can take this off of the left-hand side over here, and this off of the right-hand side over here, and I'll be guaranteed to be left with another set of scales that's balanced. So if I do that, I take away an x and a y from here, I'm just left with y. Okay, it's gone. I've subtracted it essentially. And then I'm just going to take 3 away from 5, and I'm left with 2. And I can see that I've managed to take that away, take that away. It must be that y is equal to 2. And I've solved this simultaneous equation. I can then substitute back in for 2, and it must be that x is 1. So y is equal to 2 and x is 1. That is an effective way of solving these simultaneous equations. It's like another way of thinking about it is that I've just got an extra y here, and I've just got an extra 2 here, so it must be that y is 2. You can do it like that as well. Now, our problem, actually, things are a little bit more complicated because I can't just take things away as it is. I'm not going to be able to get rid of all of them. Because I had an x and an x, when I took it away, they all went. There's an extra step I actually have to do here. I'm going to try and make my numbers in front of my x, they're called coefficients, the same. And I can do that by timesing through by 2 to make it 6x. And then I'm going to times this one through by 3 to make it 6x as well. So the blue one, I get 6x plus 4y is equal to 268. The red one, I'm actually going to write it above for reasons I'll talk about in a minute. I'm going to get 6x plus 15y is equal to 609. And yes, this is more complicated, but I've got a similar sort of thing now. I've managed to get the x's the same. So what I'm going to do is I'm now going to subtract them, just like I did with the scales before. I'm going to subtract this left-hand side from this left-hand side, and this right-hand side from this right-hand side. The x's go, just like they did before, and I'm left with 11y. And I just need to do 609 minus 268, and that is actually, you can check with the calculator, but it's 341. Suppose, coming back to what I said before, you can see there's an extra 9y here and an extra 341, so it must be, sorry, not 9y, an extra 11y here and an extra 341 here, so it must be that 11y is 341. Typically, we teach it by saying we're adding or subtracting the equations, but you can think of it like that as well. So then y, right, we managed to get rid of x. Y is then just 341 divided by 11. I've turned it into what is called a one-step equation. It's just one thing that we have to do. So can use a calculator for this. 341 divided by 11 and we get the answer. Y is equal to 31. Wait, was it 31? Yeah. We now have to find the value of x. And that can be done by substituting back into any of these four equations. I'd say let's substitute it back into one of the simplest ones, maybe this, starting one here. So then 3x plus 2 times 31, that's 62, is equal to 134. I can subtract 62 from both sides. This is called a two-step equation. I need to minus 62. Okay, you can see why this question is so difficult because there's so much you have to do. 3x is equal to 72. Sorry, I'm just finding a little space to write that now. And now I'm going to divide by 3, and that gives 24, in fact. So x is equal to 24, and y is equal to 31. So I hope my explanation is clear. It's a case of practicing this topic and trying to understand as much as possible. This question is especially difficult because you actually have to create the equations to start with, but that's kind of the norm on the GCSE now. I'm going to talk about another way we can solve this equation in a second, actually. I don't mean to confuse you, but just to think it's worth talking about. Just finally, state an assumption that has been made in answering part A. There's actually a lot of options here. I'm just going to show you the mark scheme. So I like this one. There's no diversions or detours on the way. He sets off from the same place each time. He only drives these two routes. Because, yeah, we've assumed that we have to assume that he's not driven any other routes or anything. That's yeah, they're correctly measured. They're basically saying similar things. So any one of these. Now I'm just gonna come back and show you the alternative way for dealing with this. If you're gonna practice this sort of question a lot and you're not completely confident with it, then I'd say always try and deal with the x coefficient. Just get used to it. But because often normally it's positive. But actually, when I look at these questions, I often go for the middle one because you're more likely to get plus or minus. And when you get opposite signs, you tend to add them. Right here, actually, both signs are the same as well. Now, another way we could deal with this question is to make the y coefficients the same, these numbers here. And I can do that by timesing this one by 5. Let me stick to, sorry, same color scheme. This one by 5 and the other one by 2. Okay, times this by 5, I'm going to get 15x plus 10y is equal to 134 times 5, 670. And then this one by 2, which gives me 4x. I'm going to keep it on the bottom now. 4x plus 10y is equal to 406. And now I'm going to subtract them again, but this time the y's are going to cancel. And I'm left with 11x is equal to 264. So x is equal to 264 divided by 11. See, the steps are very similar. I've just gone a slightly different route, and that gives 24, which is what we got before. Okay, we can then substitute the x back in to, let's say, the top one, and we will indeed get the same y again, 31. So I just want to talk about a different approach. There's nothing special about getting rid of the x's or the y's. You just got to pick the one you want. Well done on your effort on this question. I hope you're feeling okay about it. Keep practicing, okay?